All right, 5.5, triangle inequalities. So let's talk about this. So we have this cool kind of idea here that if two sides of a triangle are not congruent, then the largest angle is opposite the longest side. So if we know that angle L here is the biggest angle, then we know that the side that is opposite it, which would be SM, is going to be the biggest side that we have. And that works all the way through. So the medium angle is across from the medium side, and the small angle is opposite the smallest side. And so we can use that knowledge to form some relationships between the angles and sides together in the triangle. And this also helps us go backwards as well, so we can use the converse of it. So if we know that we have the biggest side, then we know that the angle opposite that is the biggest angle. So let's see some examples here. So number 1, write the side lengths or angle measures in order from smallest to largest. So if I'm going from smallest to largest, I'm going to start, and it's asking me about the angles that I've got. So I'm going to find the smallest side, and I think we can all agree that 6 is smaller than 7 and 9. So that means the angle opposite that side is going to be the smallest angle. So angle T is going to be my smallest one. Now if I want to find the medium angle, I have to locate the medium side. And for me that's going to be 7, right? So then that means the angle opposite it, angle R, is going to be the medium one. And then last but not least, if I'm looking for the largest one, I find that largest side, and I find the angle opposite it, which would be angle S in this case. And like I said, I can do this if we have sides, and that'll tell me about angles, but I can also do it if I have angles. So if angle A right here is the smallest angle, then that's going to point to the smallest side. Segment BC is going to be my shortest side of the triangle. And the same thing is true for medium. I find the medium angle, which would be 35, and that's going to point towards the opposite side there, which is segment AB. And then last but not least, we can find the biggest angle, and that's going to point to the biggest side. So segment AC is our longest side of the triangle. And so now for question 3, this one's just a little bit more. Triangle sum theorem pops up all the time. So if we have 3 angles of a triangle and we want to know something about the sides, we have to actually find those angles. So let's write an equation here. We're going to say that all 3 angles are going to add up to 180. So 7x plus 8 plus 7x minus 1 plus 5x plus 2 is equal to 180. Then I can combine like terms. 7 plus 7 is 14, plus 5 is going to be 19, so we get 19x. And then I can do 8 minus 1, which is 7, plus 2 is 9. So plus 9 equals 180. Subtract 9 from both sides. 171 equals 19x. And then we can divide by 19 on both sides to get x is equal to 9. All right, and now with this information, we can go ahead and plug that all in. All right, so when I plug in 9 to all 3 sides, we get angle A is going to measure out to 71 degrees, angle B is going to measure out to 62 degrees, and angle C is going to measure out to 47 degrees. So I will put my answer here, x equals 9. Then now that I know this, I can then find the smallest side, the medium side, and the largest side. So I can see that 47 degrees is my smallest angle, so therefore my smallest side has to be opposite that, so AB. And go ahead and pause the video, see real quick if you can get the other 2. Then get AC segment AC is my second one. And then last but not least, BC. All right, there we go. All right, a triangle is made using 3 segments, but not every set of 3 segments can form a triangle. So for example, picture that I had a line that was 10 units long. If I had a line that was 1 and 2 units long, there's no way that those endpoints are going to touch. So not all sets of 3 segments are possible to make a triangle. So we're going to talk about how we figure that out and how we make sure of that. So with triangle inequality theorem, it says the sum of any 2 side lengths of a triangle is greater than the third side length. So when we do this, we have to take all 3 of our side lengths and just check them. So for example, my triangle right here that I've attempted to construct, if I wanted to check that one, I could, right? So I could say 1 plus 10, is that greater than 2? Yep, that checks out. And I could try 2 plus 10. Is that greater than the other third side length? Yep, that checks out. And then what's left? Okay, so 1 plus 2, is that greater than 10? No, right? So there's where triangle inequality theorem fails, is that we have to figure out and we have to make sure that if we take 2 sides of a triangle that they add up to be greater than the third. And we need to check all 3 possibilities just like we did there. So number 4, determine whether the given measures can form a triangle, write yes or no, show all work. So for this one, I'm going to do the same thing. I'm going to check to see if it works. Now I'm going to do just a quick little bit of math here and type in my calculator 10 divided by 2 and figure that out, that this is actually going to be 5, 8, and 12. And so in order to see if this works, we're going to just test all 3. So 5 plus 8 is greater than 12. Well, 5 plus 8 is 13. 13 is greater than 12. That checks out. 5 plus 12 is greater than 8. 5 plus 12 is 17. Check. And then the last one, 8 plus 12 is greater than 5. And that would be 8 plus 12 is 20. So that one checks out. So this one is going to be a yes. All right, next one. All right, so we can start and say 6.5 plus 9.5 is greater than 16. When I do this and I add 6.5 plus 9.5, you get actually 16. And is 16 greater than 16? No, it is not, right? It's equal to, but it's not greater than. So this is going to not be a triangle. And we don't even have to check the other 2, because as soon as we find one that fails, then we know that it can't make a triangle, because all we need is one possibility for it not to. For exactly like my triangle over here, right? We just found one that was incorrect, and so therefore it cannot make a triangle. Go ahead and try number 6 on your own. Pause the video. All right, so this one's also going to be no, because if I do the first ones, notice that the square root of 49 is 7. So when I do 4 plus 7, I get 11, and 11 is not greater than 12. So that's going to be no. All right, find the range of the third side length of the triangles given the length of the 2 sides. So we have 6 and 11. And in order to do this, we want to find what is the possibility for the 2 triangles going to, or those 2 side lengths making a triangle. So I kind of have 2 possibilities here. I have what if the number is bigger than 6 and 11, and what if the other side is the smaller side. So I could run into these 2 triangles. So I could run into it where the side we're looking for is both bigger than 6 and 11, and the side we're looking for is smaller than 6 and 11. So in order to figure this out, we have to figure out what could that other possibility be in order to add up correctly. And in order to do this, it's actually not too shabby. All you gotta do is you gotta add the numbers. And get 17, and then you want to subtract the numbers. When you do this, you always want to make sure that this number is a positive number because distance is always going to be positive. So if you do 6 minus 11, you're going to get a negative number, but just note that you just want the positive form of it, which in this case will be 5. So now I want to know find the range of the third side length of a triangle given the length of the two sides. Well, I know that it's got to be between 5 and 17. So we're going to write it and say that the side we're looking for, x, is in between 5 and 17. So it's going to be greater than 5 or it's going to be less than 17, which is what that notation means, that it's somewhere in the middle of those two. Note that it's going to be, so that just means we know that x is going to be greater than 5 and x is going to be less than 17. So it's going to be somewhere in between 5 and 17. Notice we don't want to say equal to because then we run into a situation like this where we'd get 16 equals 16, and that doesn't form a triangle. So you want to keep it just the less than symbols there. All right, go ahead and try number 8 on your own. See if you can figure out the answer. Pause the video. When you come back, you'll see it. All right, so when I add those two sides, I get 8 plus 17 equals 25. And when I subtract those sides, I get 17 minus 8 equals 9. So therefore, like, this is complete, right? So 7, those are going to work out. So then I get 9 is less than x, which is less than 25. And once again, this is just a way to say that x is in between 9 and 25. And it's the same thing as saying this down here. So x is going to be greater than 9, and x is going to be less than 25. All right, so there's a lot of different things to triangle inequality theorem, but they do help us kind of point to a lot of different things. So make sure you do the practice, do the LT check, and there is 5.5.